This week on Titan.
Manufacturing literally saved my life.
Big chunk of titanium.
Villanova University products that go into the human body.
Build my own company just like how Titan has.
Teeth are cutting into the vertebrae.
One mistake. Our country was built on a foundation of American manufacturing.
I pledge allegiance to the flag of the United States of America.
But today, we've seen millions of jobs lost, and 100,000 manufacturing plants have been closed.
And to the republic for which it stands.
Join us as we take a stand for American manufacturing and fight to bring those jobs back home.
One nation, one nation, one nation. Under God, under God, under God, indivisible, with liberty and justice for all.
This industry is hidden from the general public, locked behind closed doors. Today, all of that changes. Every week on Titan, we're going to show you great American companies that are manufacturing and doing it big right here in America. We're going to teach advanced manufacturing techniques, and we're going to clearly show you how to bring work back to our shores. It's time to put Americans back to work. All right, have a good weekend, huh?
You, buddy.
All right, yeah. Stuart, have a good weekend, huh?
Yeah,
All right, take care. What's up, guys?
So, how's it going?
So you're on the lathes now.
Yeah, I do everything, dude. Mills, lathes.
Mills, lathes, make it
Anything,
happen.
dude.
What about him? Stepping up.
A little confident, a little cocky, but he's doing good.
He's doing good? Yeah. Keep it up, man. Keep it up. Have a good weekend, huh?
Yeah, you too.
Okay. As a father, I love just seeing my kids working. Like it's a family business. I look around this shop and I'm just like, we got all these machines. Look at this big building. But without family, it doesn't mean anything. When I first went to prison, my son Chris was just born. Tyson was 3 years old. I'd ruined everything and like there was no hope. I had 16 years in prison. And I was like, I'm never gonna see my kids again, ever.
I grew up in Maui, Hawaii. It was me, my brother, and my mom. You know, it was pretty hard. I didn't really see my dad too much. He was in prison right when I was born. We would talk on the phone here and there and see him sometimes, but I mean, it's hard growing up without your father.
I tried to do something that would bring money into my family so I could take care of my kids, so I could bring them to live with me. Walked into a machine shop, got a job for $9 an hour. Everybody knows the story. I worked my way up.
I moved in when I was 16, and it was pretty hard, you know, because I had my own habits and stuff. And, you know, I mean, 16 years of not having that, it's going to create conflicts and struggles. And
me and Chris, we're like the same person. I look at him, it's almost like looking at a mirror, you know, when I was younger.
Yeah, after I graduated high school, my dad made me work at the shop, and I didn't really want to. It just wasn't what I wanted to do.
I was just saying, like, look, work wherever you want, but if you're not gonna work somewhere else, you're gonna work in the shop. I tried to put that discipline into my son, you know, and it backfired.
So when he was telling me I had to do it, I kind of rebelled against it. I went to the East Coast, got a job over there, and I was doing my own thing over there.
Chris left. I love Tyson, you know, I love Titan, my other son. And now I got the twins, Gabrielle and Nathaniel. And yet there's part of me that is broken as a father. One day I woke up and I had this horrible dream about my son. Like I just woke up in like agony. All day, all I could think about was Chris. And finally I got him on the phone. And I just told him, like, Chris, man, I love you. Like, I love you, man. We're family.
it just sounded different, you know, and I saw a totally different side of him. We both said, you know, enough's enough. Like, we should be there for each other, and we grew up thousands of miles away, you know? I mean, why continue?
I'll help you rent a place. I'll help you get a car. You know, we'll go buy some furniture. We'll just come, father and son, come together, and we'll help lift you up into a place. And then you'll be able to sustain that. And I was praying, like, Lord, like, please, like, let my son just do good. Let him see the light. Let him just come here and do good.
Me and him, we started treating each other a lot differently with a lot more respect both ways, and I just want to have a great relationship with my family. I don't want to be by myself. I bought in this time, 100%. I believe in what he's doing. I see the lives he's touching and stuff, and you know, I just want to help in any way possible.
I just knew that he would do remarkable.
I wanted to go straight into programming. You know, I never even bothered with it before, but this time came right back, went straight to the programming room, started learning. And every day I work on my skills and I progress every day. I just want to become the best I can be and really put in the work, and I don't want to just be an average programmer. You know, I mean, it's time for me and my brother Tyson to take the shop and just take it to another level.
I thought I could never be a dad, and yet, because of this shop, because of a constant improvement and constantly trying to better myself, I got an opportunity to raise my kids. Hey, what's up, Chris?
Yeah, what's up?
How are you?
Good, how are you?
I thought you went home, man.
Nah, I just stayed here doing the work, yeah.
So you're off the clock, just doing it on your own?
Yeah, just trying to perfect it, you know, get good at it.
I'm really proud of you that you've been, like, ever since you came back, like, you've just been doing so good, man. It's just great having you, you know what I mean?
Yeah.
Hanging out, barbecuing away from work, and then just, you know, seeing what you're doing, you know what I mean?
I want like some titanium jobs, some inking out, anything crazy like that. Like, I want that.
You're ready, you know?
Yeah, I'm confident.
Cool.
Ready to do it.
Opportunity's coming.
Yeah, let's do it.
Well, I'm getting ready to take off. You want to go grab a bite?
Yeah, for sure. Yeah, I'm done. I'll just close this up and I'll head out.
Okay, cool. I'll meet you out.
All right, cool. Yeah. Programming has become like this kind of bond between us now, and we talk about it all the time. I'll be at his house, we'll be talking about speeds and feeds and improving stuff and taking stuff to the next level, and it's just this thing we're both real passionate about, so it's cool that we have it in common and we can talk about it anytime now.
Awesome. Everything's turned off?
Yeah, everything's good.
Cool.
You know I'm mastering this HSM Autodesk software, right?
You're getting pretty good, man. You're getting pretty good.
It's time for a raise, dude.
Not that good. I think I got to teach you a few more things.
Next on Titan.
Big chunk of titanium, running over 100 inches a minute. Built my own company, just like how Titan has.
Thanks for watching this free episode of Titans of CNC. If you love what we're doing, please subscribe to our YouTube channel below. And if you want to learn this trade for free, go to academy.titansofcnc.com and we'll learn it together and take it all to another level. Boom.
Hey, Sean, is Titan in there?
Hey, what's up, Zach? It's Titan.
Hey, I've got Mike from MK Precision on the video conference. You want to come up to the front?
Yep, I'll be right there, man.
All right, see you.
Okay, thanks.
Hey, Mike, look who I found.
Mike, it's good to see you, man. We're 1 week away, coming down to MK Precision in Pennsylvania.
Yeah, we're excited to have you, man. Can't wait.
Oh, man, it's been a while. How is it over there?
Oh, it's doing good, man. We're banging parts out every day.
So you guys are making parts that go inside the human body, hooking our bones together, and then you're making parts that are going into space right in Pennsylvania?
Yeah, it'll be great to have you. We have everything lined up for you, ready to show you what MK Precision can do. So, hey, I know it's only a week away, but we have a special project for you. I have a collaboration going with the Villanova University, and the students are building an SAE race car to compete against well over 100 teams all over the world. It's a titanium upright. It's all four corners of the car. It ties all the suspension together. It's a critical component, and that's why they picked us to make the parts. But I know you can knock them out just like I can. I just don't have the time.
All right, so go ahead and send the solid model over to Zach. We'll check it out. We'll get right back to you. And in a week, I'm coming to Pennsylvania, MK Precision. It's gonna be awesome.
All right, man, we're excited to have you.
All right, man, I'll see you later. Say hi to your brother, huh?
Will do. Good to
right.
see you, Zach.
Yeah, good to meet you.
I just got off a video conference call with Mike from MK Precision, and he didn't throw a wrench into my work week. He drove a car right through it. Came with a challenge to build a titanium suspension upright for the young engineers at Villanova University. He knew I was coming out, and now he wants me to bring this part. I went in and talked to my team. I talked to Dana, and of course he was giving me some attitude, but I gave him an attitude adjustment and solved that problem. I gave him my son Chris, I gave him Stuart, I took him off the machine, told him to get on the software to start programming the job. I ordered the material from TMS Titanium. It's getting here first thing in the morning. We're all set to go. My other guys have come in line to take care of my other customers, and we're rolling.
Right now, Dana has me doing a setup on the 5-axis. Currently, I'm grabbing tools for him right now. You might not think that selecting tools is that big of a deal, but the slightest variance or a small chip in the tool can be the difference in succeeding and failing. There's a million different tools, and as a machinist, you have to master all of them. Just looking at the MCO end mills, you have a 2 flute, 3, 4, 5, 6, 7, 9, 13 flute. Those are the different cutting surfaces, and each design has a different purpose. And then you gotta look at what the end mills are made of, the different coatings, the different lengths. When cutting titanium in Inconel, you have to master it all to be efficient.
Just got done programming this big chunk of titanium for MK Precision using Autodesk Inventor HSM. It's upright for a little race car for these college kids. Gonna start out with facing this thing. This is a big chunk of titanium. It's gonna be a lot of roughing using IMCO end mills, running over 100 inches a minute. They're gonna be tearing it up. Right now I'm finishing the body of the part, getting rid of all the material around it. I'm running heavy coolant on this. Titanium can ignite. The speeds and feeds I'm running at, can't take any chances trying to run dry for the show or anything. So I'm gonna be blasting coolant on those tools, making sure they last. If I'm using Cobalt standard drills, I'd be pecking, taking a chance of breaking drills, put the entire process in jeopardy. Got a center bore that's got to be held real tight for the fixture on the second side that Titan designed. There's also some pockets on the part. Because of how deep they are, got to use smaller end mills. When doing a part like this, you got to have a good strategy. Our strategy is to go nice and deep, take a lighter cut radially, and just jam through it. These are the type of strategies you need to implement to be able to compete in manufacturing. There's a lot of shops out there that aren't using the latest technology. This op would be taking all day for them. This is what you have to do to be competitive in America. What's up, Sean?
Hey, Dana.
Got the suspension upright for MK Precision.
It's a cool part.
A lot of the dimensions aren't on the print, so I want to go make you a print off the CAD model, and then you can check this out.
All right, I'll meet you there in a couple minutes.
Right on.
Dana just brought me this part, which I know next to nothing about, except that it's a huge chunk of titanium, and it's gonna end up on a race car. It seems like a moderately complex part, but to make things more interesting, I received a minimum dimension drawing. So I ran to the programming room and got some supplemental data off of the CAD model, which I'm now using to form my cogent and very comprehensive dimensional analysis. It's pretty simple stuff, really. All I have to do is check lengths, widths, heights, hole sizes, locations, depths, profile, perpendicularity, roundness, flatness, internal and external radii, and all my edge breaks. Once I'm confident that all of the physical elements are in their proper places, I'll take the part over and run some gauge pins through the holes to double check the size. I'll perform a visual examination looking for dings, dents, scratches, bad blends, and unwanted tool marks. Once I'm satisfied, I'll take the part back out to Dana and give him the green light to go ahead with production.
right, so the first operation on this titanium suspension upright is complete. Dana did a great job removing all the material. The surface finishes are absolutely beautiful. And now we gotta flip it over and 3D contour surface the entire part. Then we're gonna take it down to the lathe department, and then Tyson will pop in a few O-ring grooves, completing the part. So today, I'm gonna show you a cool technique. I got some partners, and they are awesome. There's a company called Mighty Bite, and these guys at Mighty Bite create clamps. Special clamps, machinable clamps, they clamp onto odd surfaces. This part has an odd shape. So what we did is, we went to the Mighty Bite quick change pallet system. Here's the pallet that we made. This guy right here is a Mighty Bite ID expansion clamp. It's gonna expand inside this diameter, locking it in place. So basically we're taking this guy right here and we're dropping it down. In machining this plate, we machine the profile of the part within like 1,000, so we can lock the part right down inside and it can't move. It's low enough so no tools are gonna hit it, and it's gonna keep everything perfect. This bad boy right here drops down. It's gonna wiggle it right inside. The expansion clamp expands, so as it goes in, it forces it out. So I grab this guy right here. Boom. That's it. Thousands of pounds of force. Grab these little guys, 2 expansion clamps right here. Drop this guy in. Done. This guy in over here. Turn it. Boom. We're ready to go. I got these handles right here. No matter what you do, that part cannot come out of here. All right, so we're locking this plate right here, right over the 4 pins. Drops down, already solid. We got the 2 diamond precision pins that come up and orientate this plate perfectly with intents. Now I grab my T-handle right here, my hex wrench. Go ahead and tighten this bad boy down. These pins also, as I tighten them, they're expanding inside. So since the entire plate is precision cut, and each diameter is precision, as it expands, it just locks it in place. There's nowhere it can go. That's it. It's 100% rigid, ready to go. We're ready to cut some titanium. Boom. Next on Titan. Is it beautiful?
Dead nuts.
Titanium products that go into the human body. One mistake. Everything is going really good with the suspension upright. But before we start the second operation, I want to take you guys on a journey over to Virginia, where we recently visited Danville Community College and the Gene Haas Center for Integrated Machining. They're bringing the individuals into the college to teach them manufacturing, and they're bringing up a young workforce. They're doing it right at Danville Community College. Check it out. Hey, Troy, very nice to meet you.
Yes, sir. Welcome to Danville Community College.
Oh, thanks for having me. Advanced CNC Machining right here in Virginia, making it happen. I love it. Manufacturing literally saved my life. I think when I was 14, I'd already been arrested 21 times. When I was 22 years old, I was not only in a 16-year prison sentence, I was doing 6 months in solitary confinement. I had lost my way in life. I got out of prison early, and one day, I just had enough. This is a community where you actually lost 15,000 manufacturing employees?
Yeah, our community is very rich and steeped in manufacturing, but it was a different type of manufacturing. Over the years, we've been one of the world's largest producers of textiles. We had 12,000 employees in Dan River Mills, and that industry no longer exists. So we've put these programs in place to retool America. What we mean by retool America is give our young people the tools they need to manufacture something different.
Sometimes opportunities come in the weirdest places. I looked in a paper and I saw saw operator.
I had no idea what a machine shop was though. And they had these CNC machines. When I stood in front of it and I opened the doors and I looked at the numerical control, I just got it. And I loved being there.
These students walk into this space and they can see the relevancy of it. They see modern technology, vibrant space, and they know instinctively that there's a future for them.
What you guys are doing here, training our workforce, training the younger generation, bringing them up with the new technology, new skills. You guys are leading the way so we can keep those jobs here. It was all about putting the aggressiveness that I used on the street, the aggressiveness that I used in prison into manufacturing and then taking it to a high level. If you're running 2 parts all the time, figure out how to run 100, figure out how to run 30 parts. And what it equates to is a cheaper part. Big companies need a profit. And if they can't get their profit right here, they believe, they're programmed to think they have to go overseas. Most machine shops are only running at 20 or 30% of their capability. So if we can take it from 20 to 30% and take it up to 60, 70%, you're gonna bring all that work back.
That's the message that we want to get out. Manufacturing factories of today and tomorrow, this is it right here. These students actually can see taking those 3D models and turning those into complex shapes and hardware that they can hold in their hands, and see how that they can actually, the creativity they have, that they can turn that into something they can hold. I think that's what's so exciting, and what our students are so excited about, being a part of this first class here at the Gene Haas Center.
Recently, I've been able to take all my skills I've learned here at Danville Community College, put them together and compete in the Skills USA National, and placed 4th place in CNC turning. And once I get out of school, I'm one to be able to build my own company just like how Titan has.
So this is a real-world manufacturing plant, but it's an educational institution.
They're in school, they're learning technology, and you keep giving them those problems to solve. It helps them gain confidence, not only here, but on the outside. And that's what happens in the real world. When they're working for somebody else, they have to solve problems, they gotta fix things, they gotta make it happen. There is nothing I do more than make sure my quality is perfect. We're inspecting every 5th part, every 10th part. We're visually looking at every single part. If we're dealing with tents, we're inspecting 100%, even though it's not called out. If you inspect your parts, you're not gonna have garbage. It's as simple as that.
It's amazing what some of these bright minds, the ideas that they have. I think it is a new model in training. I think it takes training to a whole new level in the world of CNC manufacturing training. And I think that it's going to make us very competitive here.
I mean, this place is immaculate. It's beautiful. I love it. It's high tech. It's awesome. If somebody says you can't do something, take an honest look at it, and if you believe and know that it is possible, go after it, man, because we're all built different. We have different gifts. Go after it. And understand that there's a process and it takes time. If we're gonna step into a manufacturing facility, let's be exceptional. The secret is solving people's problems, finding a niche, and taking your quality to the highest level at an affordable price. That's the secret. Thank you guys, appreciate it. Boom. In Danville, Virginia, American built. Boom! That's it. It's 100% rigid, ready to go. We're ready to cut some titanium. Boom! The first operation is done, and now we've flipped it over and put it into our amazing fixture plate. It's solid, it's rigid, and we're ready to go. So on the first op, we profiled around it. We did the major bore, did a few holes, did a few things. Now we're flipping it around.
we have the material that we held on to. We call that the hat. This is a thick piece of titanium that's hanging on the outside. So what I'm gonna do is use an end mill, and I'm just gonna take a nice fast cut going all the way around it, coming from the outside in, so it never gets weak. It just strengthens as you get to the core of the part. One of my favorite parts about the Autodesk Inventor software is adaptive clearing. The software already knows what material is there and what's been taken away. So I'm using the adaptive clearing on the second side with an IMCO 1/2-inch end mill, and it's roughing all the material so it's nice and tight to the solid model. So as you can see right now with the tool paths, it's just going and it's hogging everything out. I've told the Autodesk software to stay 30 thousandths off the surface of the part during this roughing cycle. Gives me a nice amount of stock to come back and use my finishing ball end mill to clean the whole part up. So now that I did all the adaptive, I'm gonna come over here and I'm gonna clean up these surfaces. See the material getting cut away? Just wrapping it back, taking another cut. I'm just cleaning those surfaces right there. Now we're gonna finish machine the 3D surfaces. You can see the tool making the cuts all the way around it. And it's just working itself in. When you get close, you can see each cut. Boom, 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 boom. We're doing the last 3D surface. 5,000 step over, running hard and fast in titanium. Once this is done, the part will be complete. We're gonna take it out of the machine. It's for the young engineers at Villanova University in Pennsylvania. It's gonna be like, ah. And they're gonna assemble it, they're gonna race their car, they're gonna win. Boom, that's what America is about. What's up, man? Is it beautiful?
Dead nuts.
Dead nuts?
Perfect.
Ooh, I love it, man. Let's get it in the shot. Let me know what he says, all right? Thanks, man. Dana just finished the second operation on this suspension upright for Villanova University. I'm having him take it into Sean into inspection. Sean's gonna check it out with the CMM now that the part is almost complete. Make sure everything's perfect. Once he gives me the okay, once he says it's dialed, I'm gonna take it over to my son Tyson, and Tyson's gonna finish it off. Tyson!
Hey.
How are you, man?
I'm doing all right.
You almost got those jaws cut?
Yep, they're almost done.
Tyson has the pressure now because it's at the end of the day, he's doing the last machining operation, and if he makes one mistake, so long you don't mess it up, it could scrap the entire project. No matter what, tomorrow I'm flying out to Philadelphia and I need to have this part.
I think you can get that tolerance.
CNC machining, baby. Are we good?
Yeah.
All right, thanks, huh?
Yep, get this done.
Let me know.
Got this crazy looking part from my dad. Not doing too much, I'm just putting some O-ring grooves, and I've got a super tight diameter over here, but it'll be a piece of cake. Just gotta get these done as soon as possible. It's going on a plane to Pennsylvania. I made some soft pie jaws. I'm gonna hold on to this ID right here. It'll be no problem to hold all these tight diameters I've got on this side. As soon as I'm done with this side, I'm gonna flip it around. I'm gonna hold the ID from this side, and I'm gonna do the exact same thing. The program is the same on both sides. It's 6AL4V titanium. It's a very hard material, very tough, but I'm gonna make it perfect.
Next on Titan.
Grab the machines, throw them in my dad's barn.
Villanova University.
And this barn will literally run for 48 hours, unmanned.
Is it gonna start?
Oh, man. One of your cameras fell. You guys gotta be careful. Sorry, man. We don't have time for this. Yeah, luckily everything's fine, but you gave me a heart attack. You gotta be careful. Find where I was in the program again.
So Tyson did an absolutely amazing job on the last operation. Sean checked the parts out, made sure everything was absolutely dialed. Shaney packaged them up, and I am on my way. All right, we're back on the East Coast. It's a rainy day, and we are in Warminster, Pennsylvania. We're going to MK Precision. These guys are awesome. They got a great attitude. They got like 40 CNC machines. They make crazy medical parts. It's an incredible manufacturing story. So let's get in here and check it out. It's going to be epic. Good morning. How are you?
Good morning. I'm great. How are you?
Awesome. I'm Titan.
Hey, you're right on my desk.
Oh my God.
Hey, Mike. Titan's here for you. Okay, I'll let him know. He should be down for you in just a moment.
Awesome. Thank you very much.
You're very welcome.
Cool.
I started my career in machining tech school. So while I was going to high school, I'd split the day and go half tech school, half high school. While I was developing my career, I was diagnosed with scoliosis, a curvature of your spine, and I needed spinal fusion to correct that. My spine was broken. It was fused with the rods to keep the correction permanent. All the hardware that was in my body are the same parts we're making on our machines now.
Mike,
Hey,
good to see you.
Welcome to MK Precision.
Awesome, awesome.
This is my brother Brian.
Hey, Brian.
Nice to meet you.
So it's a family business?
Absolutely. My dad's outside working on machines right now.
That is awesome. MK Precision, you're
Yep.
making precision components out of titanium that actually go into your body.
Sure, I've had parts myself, yeah.
You guys are making it right here in Pennsylvania.
Absolutely, man.
Boom!
Boom.
Yeah! That is awesome. So, got that titanium part for you?
excellent. We need
that
it.
suspension
Villanova
upright?
needs it. Great.
Cool.
These guys got a great program, and we really need the part, and something they couldn't make in their own shop, so it's great to have you guys helping us out.
Cool. So they fabricate, they do all the carbon fiber, and
Yeah, a
they're
little bit of
racing.
everything. Yeah. Some of the advanced CNC machining, they don't have the capabilities in their facility to do that, so that's why they called on us, and we were too busy with our shop making medical devices, so that's why we called you. So it's a
You guys
good
are like
job.
saving lives, making it happen.
Absolutely.
Well, that's the least we can do. And now I can't wait to show the viewers this incredible facility that you guys have. You guys got machines on this side, you got machines on this side. It's making it happen right here in Pennsylvania. Oh,
Let's go, Titan. Let's go show you around.
sounds good.
You want to be a success, you want to achieve, you do your best in bringing up your children. I have succeeded with all three, and when they ask me, what do I want yet in life, I already have it all.
Hey, Ryan.
Hey, what's up?
This is Titan.
Oh,
Ryan,
nice
nice to meet you. Making it happen.
Oh, yeah, you know.
Oh, that's awesome.
This is the Villanova upright. Why don't you take it into quality, get it checked out for us?
Yeah, I can do that.
Thanks, bud.
No problem, man.
Machines just stacked in lines all the way down. Floor is clean. You can eat off it.
Thanks, man.
I don't recommend it, but you can.
Yeah, that's awesome. Where's medical, right? It's almost like a clean room.
It's gotta be clean.
MK Precision. I love that stamp of excellence. This whole shop has a stamp of excellence, American quality. So Mike, you were working at other machine shops.
Right.
Right?
Yep.
And then you just decided to go out on your own. How did it all happen?
The only way to do it was to go all the way. Grab the machines, throw them in my dad's barn. I had to talk him into a loan.
Every day I had a team of Clydesdales, and I used to have to go out and clean up. So Mike would come out and help me clean up the fields with the tractor and the shovel until I finally said yes.
Had to hire my brother, train him up, took him from cheesesteaks to bone plates over 10 years.
Wait. Philadelphia cheesesteaks, right?
That's the only cheesesteak there is.
That is awesome.
Essentially, I've always made stuff that went in the body in one form or
They
another.
both, and they're all American built.
Of course.
Absolutely.
That is so.
Being a mechanical guy myself, I talked Mike into going into trade school to get started, so I wanted him to kind of like follow the same path. And that's how it all started. 10 years ago, we started the business in our barn. Here we are 10 years later with 40 machines.
You guys are making a great product, titanium products.
Yep.
They go into the human body.
Absolutely.
We know the pain that's caused without it, and we know what you need to go through to get it, and it adds another little bit of excellence to what we send out the door because we know what it does.
So if you have like heart issues or spine issues, or if you need implants, there's a good chance that those parts, those titanium parts, are being manufactured right here at MK Precision.
Absolutely.
One of our big OEMs is global, so we're worldwide. We
Worldwide.
have parts all over the place.
So we make them right here in Pennsylvania,
Yep.
shipping them out worldwide.
Sure.
American quality.
Boom.
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 Yeah, I love it.
Let's go look at a shop.
Cool. Yeah, I love it.
Let's go look at the shop.
Cool.
Automation doesn't mean less jobs. When you have the machines doing the work, you get the ability to bring more creativity in. Now we have the ability to have 40 machines with that same staff, because now we can have one guy running 3 or 4 different machines. It hones the workforce.
So you guys have your raw material comes in.
Yep.
You guys cut it yourself.
Yes.
And then bring it out to the machines.
Yep.
And just make it happen.
Yeah, we try to attack everything in a 5-axis mentality as much as possible, because we really try to optimize the 2 operations. The more times you touch, the more room there is for error. So if we have an option to do something in 5 axes, even if it's just a square with 4 holes in it, we set it up that way just for the repeatability and how easy it is to manufacture.
As much as you can get in one operation.
Yep.
Absolutely.
Manufacturing is a constant learning trend. The more you learn, the more you can adapt, the more you can add to your processes, the faster you can get your parts out, the more happy your customer is going to be with your company and the parts that you're providing to them.
So your parts are going global, right? You're shipping all over the world. To be competitive, to keep your costs down, you guys are doing a lot of 5-axis work.
We really tried to go after the swivel 5-axis bar-fed mills, just for the simple fact that we can load an 1 5/8 bar, 3-foot length, and this bar will literally run for 48 hours unmanned. It'll run its own tool break detection, so that way you don't even have to have an operator stand in front of it. It just runs non-stop, day in, day out.
And it knows if it breaks the tool, it'll go grab another tool running in its place.
Exactly.
Awesome. 6L4V titanium.
Yep.
Aerospace grade, medical grade.
Exactly.
Oh, what exactly is it?
It's a disc replacement. So if you have a herniated or bulging or degenerative disc, that would be removed and that would be placed in its position.
I see all these fine little detailed like key cuts, right? Dovetail cuts. What is the ribs for?
So when you expand the device open, those little teeth are cutting into the vertebrae that they're touching to lock it in position so that it doesn't slip out.
So they're just teeth locking into your bone.
Yep.
Holding it in place.
Think of like a neural pattern.
Wow. Absolutely love what you guys are doing there.
Thanks, man. So do we.
Doing it big.
Thanks.
Yes.
Let's show you a few more things.
Awesome.
We really like to go after complicated parts to make. For anybody that thinks American manufacturing is dead, feel free to knock on our door and come in and take a tour.
Titan, check this out. So here's one of our many bone scrapers, right? So this is a combination Swiss and then a 4th-axis mill part. So the Swiss blank will give us this, and then we fixture this into the Haas on a 4th axis, and then spin it around, get the profiles cut in, get the sharp edge on that. Check that one out.
And this just...
That's what chisels the bone away.
Bone.
Yep.
Ooh, it's almost eerie and it's so sharp.
So at MK Precision, we make the implant devices, but we also need to make the instruments as well to perform the surgery. So when a doctor needs to go and place that implant in position, if there's bone in the way, you use a bone scraper. And with a couple good wraps on the end of it, you'll knock that bone out of position and let you slide that implant in position.
You make all kinds of bone scrapers.
Yep, a bunch of them. Much like the bone scraper, this is a curette. It's the same type of device, but it's for a little bit more delicate work, a little bit more detailed work down inside cavities where you can feed it down into a little pocket and pull a little bit of bone out on the inside without having to use something as large as the other bone chisel.
American built, right here, Pennsylvania, MK Precision.
Boom.
Started in a barn, now you're worldwide, making it happen. Woo, I love it, I love it. What's that over there?
Oh, dude, let me show you.
Yeah.
If you ask me how to stay competitive in an American manufacturing environment, I would put it all in technology. You have to have the top tools in the shop. You have to have the fastest machines.
Ho ho! UMC 750. I love it.
All right, Titan, so what we have here, this is our new Haas UMC 750 SS. So what we did was we went ahead, designed up this fixture in our CAD system. What we have here now is an 8-sided fixture that holds 24 parts that are 17 minutes apiece.
So you just load it up,
load it up first thing in the morning, run it,
walk away,
come back,
runs all day.
Pull a piece off, put it through first article again, load 24 pieces back up. As long as it's done by 4:30, hit the button before we leave, get another 8 hours
Runs all night, load it 2 times.
Yep.
That's awesome.
So the theory that we've developed over the years here at MK Precision is long run times. Fixturing and multiple parts is definitely the way to go to stay on top of your game and keep everybody satisfied.
All right, Titan, so this is our Swiss machining side. There's a dozen machines over here. This is our automatic cell. They run all day, all night.
We try to work down to the smallest nominal number on your print to make the best quality parts in American manufacturing that we can for your in-body implants to never fail and always work the way they're designed to work.
Hey, Titan, the Villanova engineers are ready for the titanium upright. Let's go see what it does.
Awesome. Let's go run it.
Let's go.
See how it goes.
We adopted Villanova SAE racing team and their entire engineering department to build one of their new race cars for this year.
Even though we're dead set on helping Villanova, there's times where business comes ahead of being able to help, so that's where I called on my buddy Titan to help me knock out these uprights, and I'm looking forward to getting it assembled and testing this thing out. Titan, you're gonna love what these engineering students are doing. Let's go check it out.
That's awesome. They are the future.
Absolutely.
Well, it is the moment of truth. We're gonna meet the students from Villanova University. We got our suspension upright we made in California. We're gonna see if it fits. It's gonna be perfect.
Hey guys, looking good. Meet Titan.
Oh, Villanova University in the house.
Hi, nice to meet you.
Nice to meet you.
Hi, nice to meet you.
Nice to meet you. So you guys are engineering students at Villanova University, and you guys created this car right here?
That's right.
From the ground up.
Yep.
American manufacturing.
Basically.
Happening right here in Pennsylvania.
That's right.
And you guys are gonna race against like 150 schools worldwide.
Yep.
And this car is gonna dominate.
You know it.
With this crazy titanium part. It's gonna be perfect. You guys wanna assemble it?
Let's do it.
Our team has about 25 members. We've been in existence for about 7 years or so. It's entirely student run, so all the research, all the design, all the manufacturing, all the corporate sponsorship, everything to the logistics to getting us to the competition is done by the students.
This car is absolutely incredible. There's so much going on here. So you guys designed it, fabricated it?
Yeah, everything comes together from the chassis to suspension to driver control, steering. We first designed everything and then we manufacture it, so it's a whole different process, and here's our end goal, basically.
That's awesome. So you guys like cut the material, bent it, welded it, put it all together, everything.
So we start the design of the car with the suspension. We pick all the hard points and then we model the components themselves. Then we perform a basic analysis to see what the kinematic behavior and how that'll affect the forces going into the chassis and distribute to on-track performance. Everything from the motion ratios of the rockers and the anti-roll bars to the spring displacement itself.
Yeah, that's right. We started everything in CAD. We modeled our suspension geometry with sketches, and then from there we started actually designing the parts. So we started with the suspension components, and then the rest of the car just kind of molded itself together from there.
Are these titanium?
That's right. All the suspension components are titanium. Our rockers are aluminum.
And now you have these suspension uprights made out of 6AL4B titanium,
That's
aerospace
right.
grade. This thing's gonna fly.
That's right. This thing looks awesome. All we gotta do is check it to make sure everything fits, and then from there we'll press the bearings in, then the hub, and then we'll be ready to go.
Awesome. Let's do it.
Let's check it out. Our philosophy is to engage students and cultivate an environment of critical thinkers.
Most of our members come in, don't know, the difference between a wrench and a screwdriver. At the end, they're, engineering wireless telemetry systems, designing 3D printed intakes, fully designing suspensions, and even here just with this upright, that's Ben's part designed.
We want members to come in as students and leave as engineers.
We were very fortunate in that our first team members were, really dedicated car guys, and they knew how to get us a good foundation.
Classroom will teach you how to be a good academic, but Formula will teach you how to be an engineer.
Woohoo! This is gonna be awesome!
Excellent job, man.
Congratulations, guys.
You guys ready?
Yeah, I'm ready. Are you ready? 1 year of hard work, of design, fabrication.
We're ready.
Building it right here in America, Pennsylvania. Is it gonna start?
It's gonna start. It's ready to go.
All right, let's do this.
This episode is one of my favorites out of all that we've shot because it's about the younger generation rising up. We looked at my boys, we looked at the students at Villanova University, at Danville Community College. We looked at a father and son who started a business, the whole family came in, and now it's a global medical supplier. The youth, they don't believe in the impossible. They believe in challenging what others say is impossible, finding their niche and finding their way around the wall to move forward. I, for one, am proud of our youth, and this episode proves what they're capable of.
Really sorry, Mike actually doesn't work here anymore.
I know his dad runs the show. Can I talk to his dad? It's a bone.
Let me let this happen in the shop.
You feel that?
Surprise me.
Am I off the camera?
Coming into help program in the mills and take Dana's job. I'm just kidding. No, I'm serious.